What's up, everyone? Sam here from ByteByByte.com. Today, we're going to do a really interesting problem where we're going to find the median of two sorted arrays. So there are lots of variations on this problem, but in this particular problem, we're also going to only focus on where the two input arrays are the same length. There's a variant on this problem where obviously the arrays are different lengths, and that makes it a lot more challenging. So for now, we're going to focus on just the arrays where they're the same length. So as you can see in this example, we have two different arrays, and we can find that in this case the median is 3.5, and we can just write it out to make it super obvious, but 3, 4, 5, 6, the median is just the two middle values, and in this case there are two of them because the arrays are the same length, so the total number of elements is even, and so we're just averaging the two values. So let's talk about any questions we might want to ask for this problem. In this case, the problem definition doesn't actually specify that the two arrays are of the same length, and so that's definitely something we would want to confirm with our interviewer, because if they're not the same length, then we're going to have to do something more clever with the way that we do this. But since they're the same length, we'll go through that in much more detail. Another thing that we might want to ask is how we're dealing with this case where there are two median elements. So as you can see from the example, we're averaging them. But in theory, you could also imagine a case where maybe your interviewer wants you to actually return two elements, so you would return the two center elements instead. And so there are lots of different things that you could do there, and so it's good to double check with your interviewer. And then lastly, just confirming, the arrays are arrays of integers, and we're going to have to return a double in this case because we are doing the average, so it's not necessarily going to be a whole value. So good things to keep in mind, and let's go on and discuss how we could solve this problem. So the first thing that we could do, if we're going to approach this from a brute force standpoint, is we could just merge the two arrays, right? That's basically what I did when I was demoing how we would do this. We merge them in sorted order, and you can do that by just incrementing through. If you have these two arrays, you can just increment through, have a pointer at the beginning of each one, and continually add the lesser of the two elements to the array and then increment the pointer. So we add 1, we increment this, then we add 2, we increment this, add 3, add 4, add 5, add 6 to your result array, and then you get them in sorted order, so it takes linear time. And then we could easily find the median because if the size here is 6, so size is 6, then the two median indices are 2 and 3, or you get 6 divided by 2 minus 1, and 6 divided by 2 are the two indices of the middle elements. So it would be really easy to do that. And so that's pretty good, right? That takes linear time, which is not so bad, and you're also taking linear space because you're copying everything into another array. But we could improve that slightly by doing it without actually copying them at all. We can, by using the same technique as we used before, we can iterate through to the middle two elements. So we basically know that we need to get to index 2 in terms of our maximum, in terms of the in order traversal. So we have index 1, so we're at index 0 now, and the lesser value is at index 0. Then now the lesser value is index 1. Now the lesser value is index 2. And then now the lesser value is index 3. So we followed the exact same process of incrementing the lesser pointer and got the second and third indices that way. And so we could just average those and return that value. And that would work as well, but it's still taking linear time. We're no longer using a second array, so that helps, but it's not perfect. And so how can we actually improve this? So what we do know is we have a couple pieces of data available to us. Let's take a slightly longer example so that we can see better what's going on. So I'll take these two arrays, for example. And in this case, the average, or the median is 2.5. You could work it out yourself, but basically you have 4 zeros, then you have 10, 10, 6, 5, and then these are the center 4 values, and the center of those two is 2 and 3, so you get the average of those two. And so what we could do with these two arrays now is let's say that we took the median of each individual array. So the median of this array is 3.5, and the median of this array is 0. And now that we have the median, what do we know about the, ultimately we want to get this 2.5 value. So from the medians of the individual arrays, what do we know about the median of the total thing? So we can see that the median of the first array is bigger than the median of the second array. And that means that this array must have more elements on the high side than this array. So basically we have that we can find that for this array, the median of the two arrays must be in the lesser half of the array. And for this array, the median must be in the greater half of the array. Because otherwise the medians would be equal. So if these two medians were equal, then that means that both arrays have the exact same spacing of the elements on either side of the median. And so if the median was equal, then we'd know that we had the median. Because if the median was the same for both arrays, then it would be the median would stay the same. And so in this case, since we know that the median of the first one is greater than the median of the second one, we know that the values that make up our median have to be either in the second half of the first array, the second half of the second array, or the first half of the first array. And so we can recursively break this down into two subarrays. So we'll get 1, 2, 3, 4, and 0, 0, 10, 10. And so I should also point out that in this case, our median is actually including these two values. So we want to make sure that we are actually going to go 1 over the middle point. And so in this case, like if it's even, splitting the array in half would actually just result in this length 3 array. But since the median could include this 3 value here, we're going to make sure in the case of it being even length, we're actually going to go 1 over. And so we're going to take this length 4 array and this length, we're going to take this length 4 array and this length 4 array, and we're going to get this result. And then we can do the same thing again. So the median of this first array is 2.5, and the median of this array is 5. And so in this case, we found that the median of the second one is greater, and so we're going to do the same thing. We're going to do the opposite of what we did before. So we're going to take the second half of the smaller median and the first half of the larger median. And so we're going to get 2, 3, 4, and we're going to get 0, 0, 10. Now we can repeat this one more time. We get 3 and 0, and then we're going to split them up. And remember, again, we take and so since this case it's odd, we're just going to take the middle element. And so this one's smaller, so we take the end, and this one's larger, so we take the beginning. And so we end up with these two arrays. And now we have two arrays of length 2. And so we can imagine that we're doing this recursively, we're splitting it each time. This could be one of our base cases. So in this case, we're going to just we know that our median is going to involve one of the first elements and one of the second elements. And so we're going to if we take the larger of the first and the smaller of the second, then we get the two middle elements. Another thing that we could do is we could literally just merge these 4 into a length 4 array and take the two middle elements. It doesn't really matter, but we can do the same thing by taking the maximum of the first elements and the minimum of the second elements. So from there, we get our 2.5. So that was kind of a lot, but I want to go and just talk a little bit about this, go back to this splitting it more than halfway and just confirm why we have to do this. Because that's, I think, the one part that can get a little confusing with this. And so the key here is, to see an example of why this is necessary, let's look at this, going from step 2 to step 3. So in this step 3, if we had just taken the second half of the array, we would have ended up with 3, 4, and 0, 0. And then our median would have been totally different. So you can see that by keeping the 2 in here, we managed to ensure that we got the right answer. And so if we think about this in the broad picture of what we're doing, what we're really doing is we're just going through, and each time we're eliminating some number of the same number of elements from each end of our, if we imagine it as like a merged array. If we merged all the elements together, we'd be removing, in this first step, we'd be removing 2 from either end. So we remove 2 of the zeros, which we know are at the bottom end, and we remove 5 and 6, which we know are not necessarily at the very top, but they're in the top half of the elements. And since we're taking the median, we just need the middle 2 elements. So as long as we remove the same number of items from the top half and the bottom half, we end up with the same median all the time. And so by doing this, we are splitting our array in half each time, and we basically end up with binary search. So we get O log n result. And so let's go and actually code this up now. So that was sort of a lot of explanation, but let's look at how we're actually going to do this. So the first thing that I'm actually going to do is something that you're not going to have to do if you're doing this in other languages, but if you're doing it in Java, it's going to make our lives a whole lot easier. And that is, I'm going to create a private class that is going to implement a subarray. And so what it's going to be is it's just going to be a class that's going to have an array backing it, and then it's going to have a pointer to the first element of the subarray, and then it's going to have a size. And so that way we're going to be able to pass around these subarrays without actually having to copy it over and over again. Because in Java, if we make a copy, we're not actually able to create a subarray without copying the elements in the array. And so that takes a lot of time. That's going to end up taking us a lot of extra time to actually do all those copies. And so by doing this, we're going to keep the same backing array, and then it's going to just make our lives a lot easier because we're not ever going to have to copy anything. So let's implement this class real quick. I'm going to make a private, it's going to have static methods in it, so that has to be a static class. Just call it subarray, and then we're going to do a couple things. It's going to have a integer array, which is going to be the underlying. And this is actually just going to be a pointer to an array. It's never going to change, and so even when we change the size of our subarray, the underlying is not going to change. Then we're going to have a private int start, which is going to be the pointer to the beginning of the array, and a private int size, which is going to be just the length of the array. So I'm going to create a couple methods to work with this. And I'm not actually going to create a constructor directly because we don't really need that, but I'm going to create a method that's going to create a subarray from an array. And so that's going to create a subarray that's equivalent to the full array, and it's going to set that array to be the underlying. So I'll just do a private static subarray. It's going to return a subarray from array. And this is just going to create a subarray. So we're going to say subarray s is a new subarray, and then s.underlying equals r, s.start equals 0, and s.size equals r.length. And then we're just going to return s. So as you can see, what we just did is we created a new subarray where the underlying just points to this array that we passed in. So we're never actually copying those values or anything. And that way we're saving ourselves a lot of effort. And so now the other most important method that we're going to have is that we actually want to be able to quickly create a subarray from this subarray. Because that's what we're going to be doing. We're going to be continually breaking our array into smaller subarrays. And so what we really want to be able to do efficiently is to get a subarray of a subarray. So I'll do private static, or this is not going to be static, right? Because this is going to be instance method or a object method for the subarray. So we're going to say subarray dot get subarray, and it's going to return a subarray. So lots of subarrays. And it's going to take in 2 pointers, an int I and an int j. And so I'm going to do what's fairly common, which is that when you take, in Java, if you take a substring or you do any of these sorts of things, it goes from I is the first element, and then j points to the element that's after the last element. So, or the first element that is not included. And so I'm going to do something similar here where if I is, so what we're going to end up with is that like if I is 0 and j is 4, we're going to get the array from 0 to 3. And so that's just going to be consistent with the way that this is generally done in Java. So we'll say a couple conditions first. If I is greater than j, then that doesn't really make any sense, right? So if I and j are equal, then we get a subarray of length 0. But if I is greater than j, that really doesn't make any sense. So I'm going to throw an illegal argument exception. And another thing that we can't do is we can't create a subarray that's going to be bigger than the existing subarray. So like basically j is pointing to an index in our subarray, and so if j is greater than size, then that doesn't make any sense. So we're going to say if j is greater than this dot size, then throw a new index out of bounds exception. Right, because j is just going to be the index, and size is going to tell us how far ahead in our array you can actually look. And so that's going to be a restriction that we're going to want to put on that. And so now that we've checked that, we're going to create a new subarray. Basically the same thing as before. S equals new subarray. S dot underlying equals this dot underlying. S dot start is going to be equal to this dot start plus I, right? Because our current subarray could already be a subarray, so the start may not be the beginning. And so we need, and then these indices are relative to the subarray and not to the underlying array. So start has to be this dot start plus I, and then S dot size is going to be j minus I. So again, if we had I is 0 and j equals 4, then we have the array 0, 1, 2, 3, which is of length 4. And so we get j minus I. And then we're going to return s. So now we have our basic subarray, and we do actually need to do a couple things with this. So let's think about what we were doing when we were computing our median. So we did a couple things. We computed the median of each subarray, and then we also needed at the end, for our base case, we needed the first element and we needed the last element. And then we also were using the size because we need to be able to compute what the subsequent subarray is, so we need the current size to do that. So we're going to implement a couple methods here. Just do this really quickly. Private int get size. This is easy, it just returns the size. Then private int get first will return the value at the first element. So it's going to be return underlying start, because start is the first element. And then private int get last is going to, so let's make sure that we do this properly, right? So it's going to return underlying start plus size, but then we also have to subtract 1 because it's because the indexing starts at 0, right? So if start is 0 and size is 4, then we want index 3. And then finally, we need to get the median. And remember that this has to return a double, right? Because the median is going to be could be the average of two values. And so we have two potential cases here. One is if it's an odd length array, and one is if it's an even length array. So if it's an even length array, which is going to be if this dot size mod 2 is equal to 0, then we need to average the two middle values. So we're going to set, so we have to get the two middle values, which in this case are going to be underlying start plus size over 2 minus 1. So again, let's take our example for 4 of like starting at 0 and length 4. We want to get indices 1 and 2. So start plus 4 divided by 2 is 2 minus 1. And then the next one is just going to be underlying start plus size over 2. And then we divide this whole thing by 2. And remember also, last thing, that you need to have 2 dot or 2.0, at least in Java, because we want to do float division in this case. We don't want to do, or double division. We don't want to do that in this case. We want to do integer division because this is the index into the array. But for the final result, we want to do floating point arithmetic. And so then that's if it's odd and if it's even length. And then otherwise, if it's odd length, we're just going to return underlying. And so let's think about another example. Let's say the length is 5 and we want to return index 2, right? Because 1, 2, 3, 4, 5. And so 0, 1, 2, 3, 4. So we want to get index 2 if the size is 5. So size is 5 divided by 2 is 2. And so that's all we need. And so it's going to be, but we also need to add the start again. So start plus size divided by 2. So that's going to be our median. And so we just implemented a couple methods here. Hopefully this makes sense what we're doing. This is a little bit tangential to the problem that we're trying to solve, but it's going to make it so much easier when we actually get to the point of trying to solve our problem. So now that we have this, let's actually implement our median function. So we're going to have a public median. It's going to take in a array 1 and a array 2. And now what we first want to do is, remember, we're only doing this if the two arrays are the same length. So let's check to make sure that the arrays are the same length. And also, it doesn't really make sense if the arrays are of length 0, right? Because if they're of length 0, there are no elements, and so there can't be a median. So let's just check those two conditions. So if r1.length equals 0, or r1.length is not equal to r2.length, then we're going to throw an exception. And otherwise, we're going to call this recursively, and we're going to want to call it with our subarray objects, not the actual arrays. So we're going to, we'll overload this, and we're going to take in a subarray R1 and subarray R2. So we need to call this now, median, and remember we created this nice handy from array function, so we can just do, we're going to call subarray.fromArray R1 and subarray.fromArray R2. And then we're also going to return that value because that's going to get us our value. So now that we have the subarrays, and this is not actually changing, like we're just passing in the whole arrays, and then we're going to do everything interesting down here. So now what we want to do is remember that we had a couple cases. So we had the base case where the array was length 2, and we took the greater of the first element and the lesser of the second. And then there's also a possible base case that could come up where, that maybe could come up, where we'd have two arrays of length 1. And so I'm not actually sure if that's going to come up, but I'm going to go ahead and account for that anyway, just in case. Because if there's one element in each array, then we just need to average the two. And it could come up if like the input arrays are of length 1. So let's say if r1.getSize, and we're also going to assume that the two inputs are the same size. And we have to do that because well, we could check that they're the same size, but if they're not the same size, it means that we're making a mistake somewhere else. And so as long as the rest of our code is correct, these two have to be the same size. So r1.getSize equals 1. Then we're going to return r1.getFirst plus r2.getFirst divided by 2. And remember, it's floating point arithmetic again. And then if the size is 2, then we're going to need to do something where we took the max of the first one and the minimum of the second one. So we're going to do return math.max r1.getFirst r2.getFirst plus math.min r2.getLast r1.getLast, close those brackets, and then we're going to divide that whole thing by 2. So now we have our two base cases, and hopefully those should make sense if you understood what we were doing earlier. And now let's do, so what do we want to do otherwise? Otherwise, we want to get the two medians and then go from there. And then we're going to say if the medians are equal, then we have our median, and otherwise we're going to split things up. So we'll say double median 1 equals r1.getMedian, double median 2 equals r2.getMedian. And so if median 1 equals median 2, then we're going to return median 1. And otherwise, now is where we have to pay attention, right? Because now is where we need to make sure that we're actually getting the right indices. And this is definitely the easiest place that we could screw this up. So I'm going to copy this example in again, just so that we can use it when we're figuring this out. So we'll start with if median 1 is greater than median 2. So if median 1 is greater than median 2, then that means that we want to take the first half of median 1 of array 1 and the second half of array 2, right? So in this case, it was 3.5 and 0, and we took this subarray and this subarray. So if in this case, so we're going to get that we are calling our function recursively, so median, return median of r1.subarray, right? So we're taking a subarray, and now is where we have to be careful with this indexing. So we're taking the first half, so the first index is 0, that's easy. And then we want to actually pass in j is going to be, in this case, 4. So because we're going to go from, we want to take the first 4 elements and go from index 0 to index 3 inclusive, or index 0 to index 4 exclusive. So the length is 6, we want to get 4, and so we're going to end up with doing r.getSize, so the size of the array divided by 2 plus 1. And we should confirm that this is the same, that this also works if we have an odd length array, because we want to make sure that it works for both cases. So in this case, if we have the odd length array, then we want to get the same value, right? We want to, whether it's odd or even, we want to point to the, in this case, the 5th index. So this is basically the first number that we're not including. And so in this case, if the size is 7, we get 7 divided by 2 is 3, plus 1 is 4. And so it works in both of these cases. And so that's what we want for this one, for that subarray. And then for our other subarray, and this should again be R1, right? So for our other subarray, we're doing the reverse. So we're doing R2.subarray. And in this case, we want to take the end of it. And so we're going to, but we want to do the same thing. So in this case, we want to point to the first element because it's inclusive. And then we're going to pass in size as the second one because it's exclusive. So here we're going to point to this. And so in this case, it's different because in the first case, when it's the end of the array, we want the even and the next larger odd to be the same. And in this case, we want the even and the next lesser odd to be the same thing. And so our formula is going to be slightly different. And so in this case, we're going to do, we're going to have to do r.getSize minus 1 divided by 2. And remember, again, in this case, we are doing integer division. And then the second one is going to be r.getSize. And so we can confirm, we can check this function again, or this equation again, that we have length 7. So 7 minus 1 is 6, divided by 2 is 3. And we want to point to 3. And then if the size is 6, 6 minus 1 is 5, divided by 2 is 2. And we want to point to the second element in this case, right? So, or the index 2. So that works the way we expect it to. And then all we have to do now, so that's our whole thing, right? Because we're just getting the two subarrays. And then otherwise, we're going to do the opposite. So return median of r1.subarray. And the equation is going to be exactly the same. So r.getSize minus 1 divided by 2, and r1.getSize, r1, this needs to be r2. So that's going to be one case, and then the other is going to be what we had before. So r2.subarray, 0, r2.getSize divided by 2 plus 1. And so that's our function. Hopefully that makes sense. You can see that it made it way, way easier because we had this subarray class that we implemented first. So you could do this without. You could do this by adding 4 additional variables, which would be pointers to the beginning and end of each array, or of each subarray, which would work fine, although it gets a lot more complicated. And you could also do it by actually doing the subarrays or doing a copy of range, but again, that's going to be much less efficient. So let's go through a short example. I'm just going to go through this example, and then if you want to test it further on your own, you're welcome to do so. So we're going to pass this in here. We get that the lengths are not 0, so we're going to call, we now have subarray, these two subarrays, and so the length is not 1, the length is not 2. We get the median of each. We get median 3 and median 4. And then in this case, we get that 4 is greater than 3. So median, we come down to here and we say R1, we take the end subarray of this. So we're going to say now the new R1 dot subarray is going to be equal to R1.getSize, which is 3, minus 1 is 2, divided by 2 is 1. So we take the first index, and then we go through R1.size. And R1.size is 3, so we go through the second index as well and stop before we get to the third. Now R2.subarray is going to be equal to the, we're going to go from 0, so 2, and then R2.getSize is 3 divided by 2 is 1, plus 1 is 2. So we're going to go for 0, index 0 and index 1. Right, and so now we're going to come back again with these two values, and we're going to see that the size is 2, so R1.getFirst and R2.getFirst, the max is 3, and the min of the second one is 4. So we take the average of 3 and 4, and we return 3.5, which is what we expect. So there's a lot more that you could do with testing this that I'm not going to do because it would take a little while, and you guys probably don't want to watch that. So I do recommend that you do that on your own if you have time. It's definitely worth testing the entire subarray class because we're sort of assuming that that works. And with this, in general, what I would really test is focus on potential out-of-bounds index out-of-bounds exceptions, because that's something that is going to be super possible to come up in this problem because there's so much indexing and subarrays that it's definitely something to be cautious of. And so if you're going to spend some time testing, I highly recommend that you do that. So that's all there is with this problem. I hope that that clarified this a little bit for you. If you have any questions, definitely let me know down in the comments below, or come over to the blog because we have a lot of great information there and a lot of other good practice questions that you can check out. And otherwise, I will see you guys again soon.